Okay, so can I subtract these two radicals?
No.
No. And why not? Different radicands, or they're not the same square root, different radicals. So I have to simplify first using my factor trees. Okay, I like to do it like this and stop. And like this and stop. But if you go all the way down to the 2s and 3s and whatever's there, 5s, and look for pairs, that's okay too. But I stop when I see perfect squares, just to save myself time. So the perfect square of 25, the square root is 5. When I bring it out front then, I multiply it by that number out there. So 3 and 5, when I multiply, it's 15. And here, that's the square root of 36, 6. There's a 5 out here, so 6 times 5, that makes it negative 30. Now I have like radicals, so I can actually subtract. And that would be equal to negative 15 radical 3. Okay, so just a little warm up. These types of problems seem to be the ones that give us the most problems. Any questions? Okay, so going over the practice quiz. Tomorrow's quiz will look very similar to this. Okay, and that's all you got to do is that quiz tomorrow. You don't have any homework. And tonight there's no homework. I might suggest maybe looking at this again without looking at the answers and do it again just for practice. But if you understand everything really well when you leave here today, you should be fine. All right, so identify the property being illustrated. So I've got 1 plus the quantity x plus 2 equals the quantity x plus 2 plus 1. So what was different from the left side to the right side? What happened? The order was switched. So which property says we can switch the order? Commutative, right. All right, there's no n in this property. Not like community, but community. All right, but you have to tell me what operation is being used. So what else would I write? What operations up there? Addition, yeah. In order to get full credit, tell me, and it's a commutative like this or associative. You have to tell me addition or multiplication also to get full credit. If it's distributive, which it could be tomorrow, then you can just write straight, because that has both multiplication and addition or multiplication and subtraction. Okay? So it's going to be one of those three. Commutative, associative, or distributive. Associative, what changes from one side to the other? Remember? What's in the parentheses, what's being grouped, right? So just a associative example, it would look like this. I'll just use the same left side. 1 plus quantity x plus 2 equals, oops. Equals 1 plus x plus 2. So the order is the same, 1 plus x plus 2 on both sides. But on the left, the x and the 2 is grouped. On the right, the 1 and the x are grouped. So I change the grouping. That's the associative problem. Okay, you guys all know what distributive looks like when you see it, right? We'll do distributive down here with the 6. Okay? Number 2, I'll give you 2 sets, and I'll have you do one of those 2, I think. I don't think I have you do both on the actual quiz. So I did both for practice just to make sure you knew how to do each one. The U stands for union. That means just put the 2 sets together. So every number you see, you just write down. So I see a 1, a 2, 3, 4, 5, 6, 11, and 8. If something shows up more than once, you don't have to write it more than once. If it shows up, you just write it down. That's union, putting together the two sets. Intersection, upside down view, means what's in both. What do the two sets have in common? They both have a 5 and a 7. So that's intersection. So I think it's just one of those two, it's not both. Okay? All right, number 3. I gave it to you in set builder notation, and you're supposed to give it to me, the answer, in interval. I might give you the problem in interval notation and ask you to give it to me in set builder notation. I may draw a graph of a set and tell you to put it in one of those two. Or I might start out in this and ask you to draw the graph. Okay, so I'm just going to do all 3 types. Well, at least I'll draw a graph for you, just so it reminds you how to do a graph. So it's going to be from -6 to 12. 0's in here somewhere, 12's down here. Again, you don't have to write all the numbers. -6 would have a circle over it because this says just less than, no equal to sign, so that means we're not including the -6. At the 12, we would draw a solid dot because we are including the 12 because of the equal to. And then we just connect it. So that would be the graph. Okay? That's set builder. You always start with the set brace, the X, and the line, and then you just do an inequality. So maybe I'll give you this picture tomorrow, and you have to give me that for set builder. For interval notation, that's when we have the parentheses and the brackets. Okay? The parentheses mean we're not including the number. The bracket means we are including the number. Okay? So, for the -6, we're not including it. So that's parentheses. And you just put the two numbers in a parentheses or a comma between them. The 12, we are including the 12, so that's when we do that squared off bracket. Questions on what to expect? Simple, huh? Easy, you can do it. All right, number 4, we're going to evaluate. That means we're going to substitute numbers in for the variables and then use our order of operations to figure out the answer. So I got parentheses, and then X is 3 minus 3 times Z, and Z is -1, and that's squared, minus 3 times X, which is still 3 squared. So it looks like after we substitute the numbers in. If you want to put all that in the calculator and hit enter, it'll do it for you, because it will follow the order of operations. Okay? I'm just going to do the parentheses first. Inside the parentheses, I'm going to do the multiplication before the subtraction. -3 times a -1 actually makes that a +3. Okay? Well, I can still do the 3 plus 3 in the parentheses, so I'm going to do that. And that's 6. So the parentheses are done. Then exponents. Next, so 6 times 6, or 6 squared, and 3 times 3, or 9. Then multiplication, division. There's no division, but that's multiplication there. And we get 9. Questions on that? So follow your order of operations for that. Number 5 is simplify. we're going to distribute the 6. I can't subtract 4y from 2x. They're not like terms. So it's going to be 2 plus 6 times 2x, 12x, and 6 times negative 4y, negative 24y. None of these are like terms, so I'm done. It's simplified. Maybe tomorrow you'll have like terms you have to put together. You guys can handle that. Mind your way too much, Sydney? Okay. All right. Number 6. We got a big number, 3,520,000,000. We're supposed to write it in scientific notation. So what must be true about the number in front of the times 10 part? Yeah, somebody said 3.52, but why is it 3.52? Yeah, between 1 and 10. Thank you. Okay, so here's the decimal point. In order to write this number out, how many would I have to move that decimal point? 9. So when I move 9 to the right to make that, is this a positive 9 or a negative 9? Positive, yeah. You guys understand that? So it's kind of a shorthand way of writing really big numbers. Number 7, another simplifying one. You should write this, or you'll see it like this tomorrow. It'll be written the way I want it, typed out the way I want it. I didn't get it typed out the right way when I did this. But it will look like that tomorrow as a fraction. So, we're just simplifying the fraction, reducing it to lowest terms. So the first thing I do is look at the 24 and the 72. I try to figure out a number that goes into both of those. Did you guys figure out what number goes into both of them? Yeah, 24. Okay. So 24 goes into 24 once, and 24 goes into 72 3 times. You don't have to put the 1 unless it's the only number that's up there. You know, the only thing at all that's up there. If there's no A's or B's, then you need to put the 1. If there's A's and B's up there, you don't have to put the 1. So looking at the A's, I have 4 A's up top, 2 in the bottom. Where's the higher number of A's? Top, so they're going to stay up top. What do I do with the 4 and the 2? Subtract. 4 minus 2 is 2. For the B's, where's the higher exponent? Bottom. So that's where the B is going to stay. And how many will be in the bottom? Just 1, right? 9 minus 8 is 1. So if you just have A squared in the top over 3B, that's okay. You don't have to put that 1 on the A squared. Any questions? Making sense? Okay. Number 8's like to warm up. We have radicals, and they're not the same. I can't subtract the radical 20 from the radical 45. They got to be the same number underneath. So I do my factor tree again. Okay, so for this one, I can take the square root of 9, 3, times that 3, and get 9, and the 5 is left. For the 4, I take the square root of 4 because it was under the radical sign, remember? So the square root of 4 is 2 times negative 6, negative 12, and the 5 is left. So now they're the same. It's really easy now, right? 9 minus 12 is negative 3. Square root of 5. Right, Austin? Okay. All right. So simplify first. If they're not the same already. If they're the same to start, just go ahead and add or subtract. Then simplify, if you can. All right, number 9, we're going to FOIL. Two terms is called a binomial. When I multiply, there's no symbol between them. When I multiply two binomials, I have to FOIL. So first stands for the first two you're going to multiply. First in that parenthesis and the first in that, which is the square root of 9. O for FOIL stands for outside two, these two. Square root of 3 times 7. 3 is underneath the radical, 7 is not, so I just put it out front of it, like that. Inside are the inside two, the negative 4 times the radical 3, same deal. They're not both radicands, or not both outside, so I just put it out front. And L, oops, gotta do it with my eye for FOIL. And L is for last, that's these two, the last in both. Negative 4 times 7 is a negative 28. Okay, we all know that I should change this to a what? 3, right? Square root of 9 is 3. Okay, so my answer, combine like terms. 3 minus 28 are like terms. That's a negative or a minus 25. And 7 radical 3 and 4 radical 3 are like terms. So 7 minus 4 is a positive 3. Radical 3. Right. Again, stuff you've done multiple times in the past. Just reviewing them this year. All right. Number 10 is the square root of 5/6. All right. I think about it as the square root of 5 over the square root of 6. Is there a number that goes into both 5 and 6 that I could reduce that fraction? No. So since there's no number that I can divide into both, I can't reduce it. I can't leave it like this. It's not allowed to have a square root in the denominator. So what I do is whatever that square root is, I multiply it by the top and the bottom. And remember, anything divided by itself is 1, and anything times 1 is itself. So I'm just multiplying by 1 there, so I get itself, but it'll look different. Radical 5 times radical 6, I can multiply those. And I can also multiply those, but that gives me a perfect square, so I make it a 6 instead. So there's our answer, square root of 30 over 6. Any questions? Pretty easy stuff, right? A lot easier than the homework problems, right? I told you that. All right, no cube roots, fourth roots, whatever, but you could handle it if I gave them to you, right? The last one is just a multiplication problem. Maybe I'll do a division problem tomorrow instead of multiplication. All right, but it's 2 scientific notation, numbers to multiply or divide, and then you have to write your answer in scientific notation. So when I have multiplication, I just take the 2 numbers out front and multiply them. And then all you have to do is add the exponent. 6 plus a negative 9 would be negative 3. Is that acceptable? 35 times 10 to the negative third? No. No. It's bigger than 10, right? So I have to make 35 less than 10. So I have to move that decimal point over 1. Okay, so here's where it is right now. I'm going to move it over 1. So it's in the proper scientific notation. So let's think about this. It was right here. And I'm supposed to go 3 places to the left or to the right? Left. So I just went 1 to the left. Right? I just did that. So how many more places to the left? 2 more. So this exponent is negative 2 for my answer. Does that make sense? Okay? And again, you can put it in your calculator like that if you want. Okay? Parenthesis 5 times 10 to the 6, close it up, and then parenthesis 7 times 10 to the negative 9. Close it up. And it gives you the decimal answer. You're supposed to put that in scientific notation. All right? Which would be this answer. Another way your calculator will put it, if you look above your comma, there's 2 E's. You could put it in that way. You could go 5, second comma, and put 6 times 7, second comma, negative 9. And it'll do it too. So those 2 E's above the comma, second gives you that. It's like it understands its scientific notation. Any questions on what to expect tomorrow? I think it's pretty easy, but I've been doing it forever, right? But if you guys understand everything we just did, you'll be fine tomorrow. Okay? I'm not going to try to trick you tomorrow. I'm not going to make it. I'm just switching up some numbers and stuff like that. Okay? No questions? All right, so I don't have anything else for you, but I want you just to hang out in your area, try to stay apart as much as possible. You guys have done a good job. This group here is having trouble submitting. You got to get that stuff submitted before class starts, so you can get your 5 points. Next week it'll start being late 3 points and stuff. If you haven't turned some stuff in and you still want to turn it in, you get that stuff in by tomorrow, I'll give you full credit. But after that, if it's late, it's going to be docked. And remember, we get next Monday off, right? All right, so we get a 3-day weekend. And again, no homework tonight, no homework tomorrow. Austin, you know, the last time you were here, you were trying to, when the bell rang on us, you were going to do that handbook sign-off thing? I don't think you did.
I did that.
Did you get it done?
Yeah, I did.
Okay.
Oh,
They did? They switched it? Right? Okay. So you start in there tomorrow?
Yeah.
Okay. All right. Did that messed up? Understand that stuff? It'll be okay? All right, cool. Like I said, if you want to turn in some stuff, you can. I'll see them.
I'm just having issues about something
Yeah. I would go to Ken Bass.
My body, so like, I don't know why. My body.
Okay.
No, we should win it. If our on him, if we, what are we doing? Well, Perry's already moving the line, and I